Okay, we have a short lesson on 6-4 today. If you need more help, just take the time and look at some of the tutorial videos in ConnectEd. I'm going to go through the examples in the book, hopefully with this short lesson, and be able to catch on what's going on. I would like to do a little bit extra, and I'll try to not do too much extra to try to teach this lesson. But basically we're talking about nth roots. Now, in your book, or excuse me, in your chapter 6, section 6-4 material, I've posted a power sheet where you've got what the main number is, the square of that number, the cube of that number, the 4th power, 5th power, 6th power, 7th power of those numbers. You can use this, print it off if you need to, and use these numbers to get your perfect powers down, okay? All right, basically the concept is if a squared equals b, then we know the square root of b must be a. So for example, if you have 6 squared is equal to b, since b is 36, then the square root of 36 has to equal 6. It's the same thing. Okay? So if 6 squared is 36, then the square root of 36 is 6. Likewise, with cubics, if a cubed is equal to b, then the cubed root of b must equal a. So if you have 4 cubed is equal to 64, then the cubed root of 64 has to equal 4. 64 is considered a perfect cube. That should be in your list of perfect cubes under 4. Cubics, 64 cube, or 4 cubed is 64. All right, the last one, a to the 4th equals b. It's the same as the 4th root of b equals a. So again, if you have 5 to the 4th is 625, then we know the 4th root of 625 has to be 5. All right, when you do this, and this is where all of a sudden they throw in variables, and I'm going to talk a little bit about that. But a variable, when you are taking the square root of a variable, and maybe we've done enough of this, you understand it, but if you have the square root of x squared, it's just x to the 1st. The square root of x to the 4th is x squared. You're always taking half. When you're taking the square root, you're taking half the exponent. In this one, it's plus or minus, because that just continues down, 6x to the 5th. So it went from x to the 10th to x to the 5th. Now, here's the trick. In the book, they're going to put an absolute value on this. And the reason they put the absolute value is because x to the 10th is positive. X to the 10th is positive because when you take something to a 10th power, it's automatically positive. However, x to the 5th can't be always positive, so they put the absolute value signs on it to say that it's going to be positive because x to the 10th was positive. So that's why they put the absolute value signs. I don't necessarily care about that, but that's why they have it on in the book. Same likewise with this one. We have negative, that just transfers down. We have the square root of y plus 7. So we end up with y plus 7. That's our base. But we're going to do half of that, which is to the 8th power. Now this 16th is positive. It makes this positive. But 8 is also even. So it's also going to make this positive. We won't need an absolute value sign. It's only when you go from an even power down to an odd power when you're done that you need to transfer that with an absolute value sign. Okay, this is it, the rest of the notes here. So 2a is just a matter of taking the square root. So again, we have the square root of 36, which is 6. The square root of y to the 6th is y cubed. Because you're going from an even power to an odd power, you should have absolute value signs on it. All right, this time we're taking the 4th root. So we take the 4th root of 16, which is 2, not 4. That's the square root of 16. So it's 2, and then the 4th root of x minus 3 to the 12th, you divide 12 by 4. So you end up with x minus 3 to the 3rd. And again, that has to have an absolute value because it went from an even power to an odd power when you were done. 3a gives you this formula. It says the surface area of, I can't remember now what that was. Let's see. They say in the book, it's the cube root 36 pi v squared. Find the surface area when the volume is 200. Okay, so all you're doing is you're plugging in the 200. So the cube root of 36 pi times 200 squared. All you have to do is approximate that on your calculator. You plug that in your calculator. I typically would plug it in with the cube root parentheses 36 pi times 200 squared, and that should work. Which is approximately, if you do that on the calculator, it ends up to be, I did it earlier. Oh, I did not do it that earlier. I didn't write it down anyways, if I did. So that is about 165 square inches. Because we're talking surface area, it's inches squared. Okay, find the volume when the surface area is 214.5. So this time we're going to plug in 214.5 here. We have the cube root of 36 pi times x, or v squared. So what we're going to do is we're going to plug this into the calculator. I am actually going to plug in y for this, x for this, and plug it in for y1 into the calculator. So let's do that. So let's go to y equals, we have the cube root. To get cube root, I go to math, cube root, 36 pi times x squared. So I don't know if you can see that, but that's what I'm doing right here. Now I'm going to go to the table, and I am going to look for when y is approximately 214.5. So I'm looking here right now, I'm at y is at about 86. So what I'm going to do is I'm going to start my table at, instead of starting it at 70, let's start it at 150. And I go to 150 and it's 136, so I'm not quite there yet. So I'm going to start my table at 250 and see what happens. 250 gets me closer. My y is 191.9. So now I'm going to go to the table, or table set, start my table at 350 and see what happens. Now I'm getting closer. I'm 240. I'm over the top actually. So I'm going to go back and scroll back. Just keep scrolling back until I get to about 214 on my surface area. I'm almost there. I'm at 219. So 214.3 is 295 for a volume. So approximately 295 gives me a surface area of 214. 295, the units, I'm not sure what they were, but it would be cubic. Inches cubed. Okay. All right, so that's how you would do that. And that's section 6.4.